This is the day 112 video, unit 1, day 12. We've been talking about proofs in our last couple videos, and we're going to continue to do that today. But today we are focusing on proofs where we have parallel lines and transversals, okay? And so we're going back to those parallel line relationships with our transversals on some of these things that we're going to be working on. And so I want to remind you of these angle relationships, because when these parallel lines are cut by a transversal, then we have certain relationships, and you notice I'm using a word theorem on all of these today. Okay? And a theorem is a mathematical statement or idea that is proven by using other postulates or theorems or things that have been proven earlier. And so we're not going to go over how to prove the theorems. We're just going to be able to use those in our proofs as we go through this. So this is really just a basic explanation of things we already know from our previous lesson about these angle relationships when I have this kind of diagram. If I have two parallel lines and I'm cut by a transversal, any corresponding angles are congruent. Corresponding angles congruent. Okay? And that's what the corresponding angles theorem tells me. All right, so in this case, I would say angle 1 is congruent to angle 2. And a reason, if I was doing a proof, my reason would be the corresponding angles. I've heard this called a postulate or theorem. Okay, I don't care which one you use, postulate or theorem for this one, but that's how we would abbreviate it. Now, if I wanted to then go ahead and talk about these angle measures being equal, my next step would be that the measure of angle 1 equals the measure of angle 2. And the reason for that, remember when we change congruent into equals, we're using the definition of congruent to do that. Okay? And so we have this kind of relationship for corresponding angles. They're going to be congruent. I can use that in a proof. We have two other angle pairs that would be congruent also. Okay, alternate interior angles are also congruent. So in this case, angle 3 would be congruent to angle 4. Your reason, if you're doing a proof, would just be the alternate interior angles theorem. And so that's how we would abbreviate that. And again, if I wanted to convert that to talking about equal measures, the reason in my proof would be definition of congruent again. And also alternate exterior angles are congruent. So in this case, the angles I've marked 5 and 6 are alternate exterior angles, so that means they are congruent. And that's how we would write a reason for a proof. This would be your statement. This would be your reason. And again, if I wanted to change to equal measures, I would use definition of congruent. I'm not going to write that this time. If you want to, you can. But then we have one last angle relationship to look at, and that's consecutive interior or same side interior angles. And those are not congruent. Consecutive interior angles are supplementary. Okay, so if I had a situation like this, where I had consecutive interior angles, like 7 and 8 here, we would say angle 7 and angle 8 are supplementary. Notice how I wrote that out, kind of an abbreviated sentence. Your reason is still this theorem, consecutive interior angles theorem. Then if I wanted to actually use an equation, my next line of my proof would be the measure of angle 7 plus the measure of angle 8 equals 180, and the reason for that is the definition of supplementary. Okay, so I have to kind of put that into two pieces in my proof. I have to say they're supplementary with words because of the consecutive interior angles theorem, and I have to write the equation next because of the definition of supplementary. So the hardest part of this is making sure we get our equations in the right order. So let's try some examples. Okay, we're going to use this diagram here, okay, for both of these, but we're going to use it a little bit differently each time. Okay, and we're given some information here. Now notice, excuse the bell, notice they are using some algebraic expressions again. So we're going to do a more algebraic proof here, but first we have to set up the relationship using one of these four theorems. Okay, so if we start to set that up, we're going to identify all of this given information first. Line M is parallel to line N. That has to be in the given. We have to know that they are parallel lines, otherwise these relationships don't work. Measure of angle 2 equals -3 plus 10x, so on and so forth, and we're going to get all this given information written down, kind of like this. And then that's going to lead me to the rest of my proof. Now we're using angles 2 and 7. So I'm going to look at my picture and identify angles 2 and 7, and I'm going to identify that angle relationship first. Well, angles 2 and 7 are alternate exterior angles. So I don't have to write that in the proof, but I am going to write the relationship based on that theorem. The alternate exterior angles theorem states that they are congruent, and so my next line is going to look like this. I'm going to state that angle 2 is congruent to angle 7 because of the alternate exterior angles theorem. Okay? Now, in order to talk about their measures, I have to change congruent into measure. I have to change congruent angles into equal measures. So I change it to measure of angle 2 equals the measure of angle 7. And you'll remember that I said to change from congruent into equals, we use the definition of congruent. And now I have an equation that I can substitute values into. So instead of the measure of angle 2, I'm going to write my -3 plus 10x. Instead of my measure of angle 7, I'm going to write 8x plus 8. When I plug in values, remember that is using substitution. And then I solve my equation for x, because then I can plug back in to get something like that. What I would choose to do is subtract 8x from both sides, which would give you this. And if I'm moving too fast at all, you guys should know by now. Go ahead and pause that video, copy things down. Then I would add the 3 to both sides, so I'd get 2x equals 11. Using the addition property of equality. And now we divide by 2. And you do get a decimal value for x. That's fine. You get 5.5 or 5.5. That'll work out just fine. And that would be the division property of equality that gave me that. 11 divided by 2 is 5.5. And these proofs take a little bit more time here, a little bit more space. Now I'm going to go back and plug 5.5 in for x into this expression that uses x, because I want the measure of angle 7 in my proof statement. So measure of angle 7 equals 8 parentheses 5.5, because I replaced x with my 5.5, plus 8. Again, that is substitution. And finally, we just simplify all that, and if we do the math, 5.5 times 8 plus 8 is 52. So the measure of angle 7 does equal 52 degrees. And all I did was simplify. And that finishes my proof. Okay? You have to set up this portion of your proof first. Okay, you have to set this up before I can get to an equation to plug that in. All right? So here's what we're going to do. On number 2, I want you to pause the video, and I want you to see if you can start that proof. Okay, again, we're using this picture. If you need to copy it down here so it's easier to see, that's fine. But go ahead and try and get those first 3 statements of your proof kind of like this, and then we'll go from there. Now, if you get stuck and don't know how, I will show you what those are before the video continues. All right, this is what we should see. Okay, when I look at this, I'm using angles 4 and 6, and so I've written all my given information out, and that is given. And when I look at my picture, angles 4 and 6 are consecutive interior angles. So that tells me how to set up the rest of my proof. I'm going to go to that relationship about consecutive interior angles, and the next statement is that those angles I'm using are supplementary. So angle 4 and angle 6 are supplementary because of the consecutive interior angles theorem. And so the next line is that I have this equation. The measure of angle 4 plus a measure of angle 6 equals 180 by the definition of what supplementary means. That allows me to have something to plug into. And this is how the rest of the proof should go. For measure of angle 4, I'm going to replace that with 28x minus 2. For the measure of angle 6, I'm going to replace that with my 16x plus 6. And when I'm doing that, you should recognize that as the substitution property. And then I start to simplify first. Since I have x's on the same side and constants on the same side, I'm going to combine like terms. 28 plus 16 is 44x. Negative 2 plus 6 is plus 4. And since I combined all my like terms in one step, that can be my reason. Combine like terms. And now I start to solve my equation. Again, I'm trying to prove that the measure of angle 4 is 110 degrees, so I have to first have an x value to plug back in. So we subtract 4 from both sides, giving us 44x equals 176. Subtraction POE. Sorry. Scoop my paper up. Then I divide both sides by 44. 176 divided by 4 is 4. Okay? So that becomes, or that line is x equals 4. My reason is division POE. Then I can take that and plug back into the expression for the measure of angle 4. Measure of angle 4 equals 28 parentheses 4 minus 2. And then I just simplify that, but don't forget your reason, like I almost did. That was substitution again. And then we simplify, and if you do the math, you realize if I do 28 times 4 and subtract 2, it is 110 degrees. Sorry, measure of angle 4 equals 110 degrees. And that finishes the proof. So that covers our proofs using angle relationships. We're going to do some more in class and then start that assignment. If you need any extra help, feel free to come in and see me at ACT Lab or before school.